Example number 3. Again, we take a look at our denominators and we see that we have different denominators. So we would need to add this one using the concepts of dissimilar rational expressions. To do that, we first find the LCD. To get the LCD, we would need to factor the denominators first. Z squared minus 4 is a difference of two squares, so it can be factored as z plus 2 times z minus 2. The other denominator of z plus 2 cannot be factored further, so it remains as z plus 2. To get the LCD now, we use two steps. First step, get the common factor. Z plus 2 is a factor that is present in both denominators. So our LCD would contain the factor of z plus 2. There is no other factor that's common to both of them. So we move on with the second step on finding the LCD, which is to get the not common factor. We would see that z minus 2 is a factor common to the first denominator, or it's a factor that is present to the first denominator, but not present on the second denominator. So we say that z minus 2 is a not common factor, and it's going to be part of our LCD. Our LCD then is going to be the expression z plus 2 times z minus 2. The next step is to change to similar rational expressions. We do this by multiplying each rational expression by an expression equal to 1 so that our denominator becomes the LCD. For the first rational expression, which is z plus 6, all over the quantity of z plus 2 times the quantity z minus 2, take note that the denominator already makes use of the LCD. So there is no need to multiply this by an expression equal to 1. Moving on with the second rational expression, which is 1 over z plus 2, we multiply this by z minus 2 so that we would end up with a rational expression that uses z plus 2 times z minus 2 in the denominator. And this denominator is exactly what our LCD is. If we're going to multiply the denominator by z minus 2, then we would also have to multiply the numerator by z minus 2. And we would end up with the similar rational expression, or we would end up with the equivalent rational expression of 1 times z minus 2. Copying the first rational expression, we would have z plus 6 over z plus 2 times the quantity z minus 2 plus the second rational expression. By distributive property, 1 times z and 1 times negative 2, then we would then have z plus 6 all over z plus 2 times z minus 2 plus 1 times z is z, 1 times negative 2 is negative 2 all over z plus 2 times z minus 2. You would see in this last expression that we now have denominators which are the same. So from here, we then proceed with addition or subtraction of similar rational expressions. That is, we operate with the numerators and copy the common denominator. Working on the numerators, we would have z plus 6 plus z minus 2 all over z plus 2 times z minus 2. Combining the z's, this would give us 2z. Combining positive 6 and negative 2, this would give us plus 4 all over z plus 2 times z minus 2. We then try to figure out if there is a factor that's common to both numerator and denominator, which we can cancel. We can easily identify if there is such a common factor if we try to express things in factored form. So the numerator, we factor this one as 2 times z plus 2. That is, we make use of factoring by the GCMF, wherein the GCF is 2. All over z plus 2 times z minus 2. Now that things are in factored form, we can easily identify the existence of any factor common to both numerator and denominator. This we can cancel, so z plus 2 would cancel out. This would give us the remaining expressions as 2 all over z minus 2. This is already the simplified form. We finalize our answer by indicating the restriction. Again, when you work on the restriction, take a look at your denominators. If I take a look at this expression here, it made use of the denominator of z plus 2. For this denominator to be not equal to 0, then z should not be equal to negative 2. So, z not equal to negative 2 is going to be part of our restriction. But take note that in this denominator, we also made use of the factor z minus 2. For this denominator not to be 0, then z should not be equal to positive 2. That means that we have two restricted values for the variable z. So we write our restriction as z should not be equal to negative 2 and positive 2. Here then is our final answer. It's your turn now to work on such exercises. Answer exercise 7.07 in Schoology.